Good morning again, grade 10. We are still in the continuation of our topic for the second module for the second quarter, weeks 5 to 8. Right? We are in the mirror. Last meeting, we stuck in the introductory lesson for mirror. The law of reflection says when a ray of light hits a surface, it bounces. So meaning to say that it is actually like a tennis ball thrown against the wall. So again, the incoming angle is called the angle of incidence. Okay, it's always equal to the angle leaving the surface or the angle of reflection. So the angle of incidence is equal to the angle of reflection. When light hits the surface in a low angle, like on a lake at sunset, it bounces off the same low angle and hits our eyes full blast. This is the reason why sun's glare during the evening and morning is much more intense than during the rest of the day. That's the reason behind. Because, again, the angle of incidence is equal to the angle of reflection. Right? We discussed this one last meeting. Light itself is invisible, correct? Until it bounces off something, so and hits our eyes. Okay? This is how we actually see. For instance, a beam of light is traveling through space, can't be seen from the side until it runs into something that scatters it, okay? Like a cloud of hydrogen or a satellite. The scattering of light is also known as diffuse reflection. Again, please ask question if you have so that I can address your concern. By the way, have you seen already the coverage for the second quarterly exam? All right. This is included in the coverage for the second quarterly exam. And this is how our eyes interpret what happens when light hits an uneven surface. Okay. Again, the scattering of light is called the diffuse reflection. Okay. The law of reflection still applies, but instead of hitting one smooth surface of light, is hitting many microscopic surfaces. It's more like throwing a handful of marbles against a statue and then guessing the statue's shape based on how the marbles bounce. Okay. Mirrors, however, don't scatter light in this way. Okay, with the smooth surface, because mirrors is more like made up of glass or a plastic. Okay, or some of them are metallic. Okay, this is called the specular reflection. Okay, light reflects without disturbing the incoming image. So if there is no distortion, that's how mirror actually acts, right? This is called, again, specular reflection. That concept raises the interesting question. If mirrors preserve the image that hit them, why do they turn left or into right and vice versa? Why not up and down? What do you think so? Just like in my case, okay? If you're going to observe, okay, you look at my hair. I am just like looking at the mirror. You look at my hair, okay? My hair is actually folded. In my case, it is in the right, okay? You look at, it is in my right going to the left. But as you can see there, going to the right, from the right to the left, but in the case here, it's left to the right in your view. So why not up and down? What do you think so? Do you have any idea? All right, let's take a look at why. Okay, the truth is that mirror doesn't really reverse left or right. There is no reversion there. Okay, what mirror switch is front and back, like a printing press and a rubber stamp. Imagine writing something on a sheet of paper in a dark pen and holding it up to a mirror. It looks like backward. Okay, just like, have you observed the ambulance? Everybody, have you observed the ambulance? Like the label of the ambulance? It is actually written backwards. Why? Because again, mirror reflects it what? in opposite direction. Okay, that's the reason. So it is not actually the case of the mirror putting it left or having a reverse left and right, but it's a matter of our eyes interpreting on it. Okay, it looks backward, but it also looks the same as if you held it up to a lamp and looked at it from behind. So your mirror image is like light print of you, okay, not reflection of you from the mirror's perspective. So it again, this is just like our eyes interpretation. Remember that our eyes has optical nerves that again corrects the position of the images. Okay, it corrects the position of the images that we actually saw. Mirrors can be more than just flat surfaces. Next up, we'll look some of the imaginative ways to use mirrors. Virtual image. What's in a virtual image? Okay, the type of image produced by a flat mirror. Your mirror, just like your the one you are using, just like this one, okay, produces a flat image or virtual image, okay, a reflection of you, right? Even though light is bouncing off the mirror, our eyes are fooled into thinking it's coming out of the mirror in a straight line. Okay, the virtual image can't be focused. Correct. It can't be focused because our eyes are interpreting them, right? But some mirrors, like concave mirrors, can produce a real image which can be projected into a surface. Okay. Let's move now to the type of mirrors. Again, virtual images are created by a flat mirror. Okay, meaning to say it is not concave, it is not also convex rather. So it is flat, right? One quick way to change the way a mirror works is to curve it. We need to curve. It's either curve inwards or curve outwards. Okay, let's take a look at this. Curved mirrors come into two basic types. We have convex and concave. What's in the convex and what's in the concave? And their uses also. So we'll be tackling about that later. Okay, convex mirrors, which bulges outwards. Again, if it is convex, okay, do not memorize. I want you to familiarize. If it is convex, it bulges outwards. Okay. If it is concave, it actually what? Inward. Okay. It has inward reflection, right? Reflects at a wider angle near its edges than at its center, creating a slightly distorted image that's smaller than actual size. Okay. Convex mirrors have many uses. Yes, any question?
Convex is like zooming in your face.
Convex mirrors are just like your glasses. You look at your glasses. This one. Okay. This is not flat, correct? It is actually
Oh, the size.
convex.
Right,
The position of the glass. You look at the position of the glass. Okay? It is not flat. Diba? It is
bumpy.
convex. Okay? What else? What are the other examples? How about your magnifying glass? Have you seen your magnifying glass? Okay, your magnifying glass is a convex mirror. What else? How about the mirror in the department stores? Have you seen those? Mirrors in the department store, like they usually put it on the sides so that you can actually see the other side also. The purpose of that is for security. Okay, those are concave or convex, rather mirrors. These mirrors has a lot of purpose, has a lot of uses. Okay, what are some of their uses? Okay, the smaller size of image means that you can see more because it has a wider view. Okay, just like what I'm using now. I'm using a convex mirror. Okay, hence their use in safety mirrors. Okay, the one in your grocery stores, those are safety mirrors for security purpose. This is why your passenger side mirrors, again, your side mirrors of your car and in your of your motorcycles are also using convex mirrors. Says that objects are closer than they appear. Okay, if you're going to look at it, it looks like you're too near in the mirror, but again, you are actually far in the mirror. That's reality. Some department stores have reportedly placed convex mirrors in their dressing rooms. Why? Slightly bends at the top of at the top and bottom and make you look taller and thinner. That's the reason behind the dressing rooms. Department stores, they're using this one, right? How about concave or converging mirrors? Okay. Curve inward like spoon. Okay. The curve there is inward. Okay. Like a spoon, the side that holds the soup. This gives these mirrors the ability to create an image when their curvature bounces light to a specific area in front of them. Okay, this area is called the focal point. Okay, from far away, the object is seen upside down, but to get closer and past the focal point, the image flips and magnifies. Okay, concave mirrors are used in everything from shaving mirrors, okay, to lighting and Olympic torch. There are some unusual types of mirrors also. We have non-reversing mirrors. Okay, these are patents for non-reversing mirrors go back as far as 1887 when Genderby created one by placing two mirrors perpendicular to each other. Okay, they are called the non-reversing mirrors. The second one is acoustic mirrors. Acoustic mirrors are huge concrete dishes built to reflect and distribute sound instead of light. Acoustic, okay? The English military used them before the invention of radar as an early warning system against air attacks. Two-way mirrors, this one, okay? This is interesting one. Why? These mirrors are made by coating one side of the sheet of the glass with a very thin and very light reflective material, then coated side faces the lighted room. Some of the light reflects and some goes in the dark room behind the mirror, making it possible to see into the lighted room but not out. Okay. If you ever watched the interrogation scene in the police show, you have seen, yes, those are actually two-way mirrors. You cannot actually see them, but they can actually see you. This is really interesting. Why? There are some reported cases that dressing rooms has two-way mirrors. There are some that they can actually see you in the dressing room, but you cannot see them because it is a two-way mirror. Okay. Glass is also a mildly reflective material. This is the same reason that seeing outside at night is difficult if you turn on the lights in your house. Correct. So again, just be careful of this. Again, there are some dressing rooms. There are some reported cases that dressing rooms has two-way mirrors. Okay, so this is the reason behind. These two-way mirrors are actually created by a glass coated with a thin coating on one side and putting again another reflective material on the other side. Right, we are done. I actually make this as simple as possible. If you're going to use this data information in your higher years, we will be talking about the angle of incidence. So talking about the computations. Like for example, if your eye is in this angle, okay, how can you actually calculate for the focal point? We should do that actually, but we lack time for this, right? These are just few. I make it as simple as possible in order for you also to internalize. Okay. Maybe, hopefully, in your higher years, in your grade 11 and grade 12, you will be discussing about the angles of incidence and the reflection. Okay, how can we actually count on the focal point? Okay, there are some formulas given there. This is just a simple topic. Why? This is if you're going to ask me about the focal point, the angle of incidence, and so on, we have formula to follow. If there are some formula to follow, it's easy to use. It's easy also to perform. But as of the moment, we cannot do it now. Okay? That's the reason behind. Question so far? Question? All right.
No.
Again, I have prepared an activity for you for today. Okay, hang on. Just give me a minute. I am still uploading it in your system. Okay. We are still, again, the one we had agreed upon. You'll be answering the module 1. Okay. Continuation of module 1 simply because this is part of your grade. We need to continue with this. Afterwards, we need to move forward to module 2. Okay, hang on. Just give me a minute. I'm still uploading it. Everybody, can you see my shared screen?
Yeah.
Yes, sir.
Right. Again, as what we had agreed upon, we'll be discussing the second quarter, but we will continue with the activities of the rather we'll be discussing about the second module in the second quarter, but we'll be continue answering with the first module of the second quarter. So again, we are now in the higher order thinking skills questions. This will actually close this afternoon at 5 p.m. All right. I want you to do activity number 5 today. This is under first module of the second quarter. Right? Do you have any questions so far? MD, can I ask an assistance for you? Can you inform your other classmates that activity number 5, higher order thinking skills questions, is now open? And
They're
again,
both offline, sir. Offline and online.
no, for online only. Offline is using the modules. I think we will have the online and offline for the report sheet, but as of the moment, we are still in the higher order thinking skills questions. All right, MD? All right, I think
Yes,
that will be all for today, class. Again, I will not be opening this activity by next meeting. We will continue with the next activity, right? Have a nice day,
Yes,
grade 10.
Thank you,
Take
sir.
care. Have a nice day. And Merry Christmas, everyone. Take care. Bye-bye.
Bye.